Welcome to the first ever online UWTMC Tape Music Club event. Thank you for being interested and checking out some of the stuff. So in this video tutorial series, we're going to be looking at how do we use machine learning as a tool to add extra interesting stuff to our performance. And so you've seen probably in some of our previous workshops and things the use of visuals to accompany music and this idea of responsive sound. The question then becomes, how do we actually develop those systems to create automatically responding musical visualizations? There's lots of interesting and easy ways to do it. This is just another one of them. The advantage of this way, though, is that it's using machine learning as a way to classify and identify different sounds that you're making. So really any sound can be an input, and you can say, okay, when you hear this sound, do this thing, and it'll make really interesting, beautiful stuff. Okay, so we're going to just dive right in. You should download some files. They'll look kind of like this set of files here. Just a second, I'm going to pull up a bigger video display here. So you'll have a couple different folders. One of them will be this one, mfcc output.scd. This is the file that you probably are going to open up first. That's one we'll look at first. There's a couple other files there that we'll use as well. The only one that I'm going to demo in this video is this one, visual oscm ml.pd. That's a processing file. You'll open that in a program called processing, and all the links to downloading and installing software are already provided, so check out those links, download the software. I'm not going to go over installation or anything like that. If you do need help with that, Google is a good friend for you, or on next week when I have the support session, get in touch and we can sort of try and figure out how to set up and configure your system to work with this. So the two files we're going to look at today are this one and this one, and you should be able to just click them and open them if you've installed things correctly. Okay, so to do that, let's open up that first one, mfcc output.scd. This is a SuperCollider file, and when you do that, you'll get this thing. Hopefully, it'll look like this. And so in this code base, this is a SuperCollider. It's an interpreted language. It's a little bit of an interesting language in the sense that you run a server, you send commands to that server, they're immediately interpreted, and then they're activated, and they're, the computer starts doing the thing you tell it to do. You'll see these comments throughout. Comments are represented by a double slash in front of a line. The computer basically will ignore all this writing and text after that comment. And there's some instructions here on how to sort of get things going and sort of run these default parts of the script here. Okay, so the first thing that we'll find then that's actually code is this line here, line 15 through 17. This is s.boot. This is a default thing that you have to do every time you run a SuperCollider script. And by doing this, what you're doing is booting the server. And so a server is basically a piece of computer code that's just waiting for you to send it messages, and it'll do something in response to those messages you send it. And so, yeah, there we go. So we booted it. I booted it by pressing Command and Return on my computer because I have a Mac. It's Control and Enter on Linux or Windows. And yeah, so you just put your cursor in the thing that you want to activate. If there are brackets around it, round brackets around it, then everything inside those brackets will get activated when you press Command Enter or Control Enter, depending on your operating system. And you'll see down here in this post window that something should happen. If you get error messages here, then you're going to be in trouble. You need to go check out your settings and things like that. And again, Google is your friend, or I can help you at the actual real-time support session I'm offering for this on October 8th. Okay, so we are able to activate something. That's great. We can also stop things happening. Right now there's nothing happening other than the server has started, but if we want to stop things, we can press Command and period, and there's nothing actually running that I can stop right now. But if you did want to stop something, you press Command and period. Okay, so here we go. Here is our first line of code that we're going to activate. This is monitoring. This is basically saying, take my input sound from my microphone, the default settings is your microphone input, and play it back out over the audio output. If you don't use headphones, this means that you're probably going to get a really nasty feedback loop. So plug in some headphones, I would suggest. Turn down the volume so it's not crazy loud. And activate that line of code. So put your cursor on it, press Command, return, activate that line of code. And so if you don't really hear anything, it's probably because like your microphone and your headphones are connected together. But for me, if I take my microphone here, sorry, I've got my microphone, and if I tap it, you can hear that coming through. So I'm just tapping my microphone. You can hear that coming through the system there. So if I didn't have my headphones in, right now you'd be hearing that horrible feedback thing. You don't really need to have the headphones going. I don't even know if you actually need this line, but it allows you to sort of make sense of what's going on, what you're actually hearing in the computer. Okay, so the next line of code here is going to set up this communication thing that we need to do. So we have 3 different programs we're going to be actually running to make this happen. We've got SuperCollider. Its job is to take the audio input through a microphone and turn it into a set of numbers that describe that sound. Those numbers are going to go to our next set of software, Wekinator. Wekinator is a program that's going to do the machine learning. It's going to take those input numbers, so the numbers that are describing our sounds, and use them as part of this machine learning task to send out some output numbers. And so we'll get into that in a second. But so basically, we're going to send some numbers from SuperCollider that describe the sounds to Wekinator. Wekinator is going to use those numbers to identify the sounds and send some messages out to a third program, processing. It's sending out classified sounds. It's saying, so the sounds that you sent in, this one's type 1, type 2, type 3, type 4, whatever we want. And so it sends out those identified sounds to a third program, processing, which we're then going to use to create some interesting visuals around these things. So we first, though, need to set up the addresses that we're going to send things to. And so here's the basic one, 127.0.0.1, 640.48. These are the defaults. 127.0.0.1, this is like saying send a message to myself over your networking. You could theoretically do this over the internet if you had IP addresses and all that kind of stuff figured out. But this is sort of a networking default that says send an internal message to myself on port 6448. These are the defaults that Wekinator uses, and so it knows to look for a message coming that way. We could test that, and we could just send a message like this. Boom, we just sent a message. It received it or didn't receive it. It's just sending a message out. Okay, so now here is where we're getting into this description stuff. So this block of code here, this is going to be taking our audio input. So here's our audio input described by that. Taking this thing called a fast Fourier transform, basically representing the frequencies are part of it, of that sound. So if it's got a lot of high frequencies or low frequencies or whatever in between, it's basically taking it and figuring what frequencies are in our sound. That's this step here. And then it's doing this other thing called the Mel frequency spectrum coefficients. This is trying to take those frequencies and bin them up and add them up in a way that makes more representative sense of the way that we actually hear. Because the FFT output, the data that this creates, it's good, but it's not exactly like, you know, in the frame of what we normally would think about when we think about how we hear sounds. And so this step is basically making these numbers more representative of the way we actually hear sounds. Okay, so to turn this on, we've got to do the same thing. So put our cursor anywhere in between these two brackets, press Command Enter, Command Return on Mac, and there you go. We activated that code, and you can see it was activated because there's a line down here, synth temp4. Temp4 is just like a temporary name for it. And there we go, it's activated, it worked. If you get any errors down here, pay attention to them because that means it's not working, sort of thing. Okay, so we'll then create a data bus. This is going to be just like a computing task thing that we need a bus or a way to store some of this data that this thing's creating to then turn it into something else and send it out. So we'll just create that. And then here we go. Here's where all the magic happens. So we actually have now created this thing that's running. It's taking in our audio. It's doing some analysis on it, and every so often it's going to say, here are 13 numbers that describe the sound. And so to actually then send those 13 numbers over to Wekinator to act as input for our machine learning task, we have to activate this block of code. And so what this block of code says is this thing R, this task R, we're going to call it R just because that's a variable name we can use. For infinity, keep doing the stuff in this bracket. And so we'll say get the 13 numbers from our bus C and send them over to Wekinator in this format. And so this is the message format that we want to have. So Wekinator knows, okay, here's the address, here's the message format, and it's all set up properly. We're going to add in this wait command here. So it's saying, you know, if we just say just do that, it's going to do it as fast as it can. It can do it really, really fast. So let's put a little bit of wait in there to ensure that we don't go too fast and send way too many messages. And so to do that, we're just going to put this 0.02 wait, so 2/100ths of a second, wait for 2/100ths between sending that message each time. So at maximum, we're getting like 50 frames a second. You can change this and adjust this. You can also change and adjust this number. So if you want 13, that's great. If you want to have 41, there's a limit to it, but these numbers can be changed and adjusted. Leave them as default still for where we're going. Okay, so did we do this? No, we haven't activated this. Let's activate that. Boom. So this routine is running. You should see your server number go up a little bit. This is basically saying how much computer computational activity you have. And so there we go. So right now we are sending numbers. Okay, we're sending numbers over to Wekinator, our next program, that are representing the sounds we have and what those sounds sound like. Okay, so I'm going to leave this video here and start a new video for setting up the machine learning Wekinator. So hopefully this all worked for you. Again, if it didn't work, there'll be a support session next week. And there's also good Google stuff. And this is like the default Wekinator example too. So I haven't modified it a little bit by adding a few more comments, but there's good support on the Wekinator website as well. Okay, see you in the next video. Bye.